Okay, so this is a follow-up tutorial about moles calculations and reacting masses. So the previous video is quite a simple example, and this one is a little bit more intricate. It requires a little bit more thinking. So what we're looking at is we're looking at task 13, question 5 in the booklet. So this is sort of split into two parts. It's part A and part B. So it says calcium hydroxide is manufactured by heating calcium carbonate strongly to produce calcium oxide. They're adding a controlled amount of water to produce calcium hydroxide. And that's what these two equations up here are talking about. So this is the first part, this is the second part with the calcium oxide reacting with the water. So, now the fact that there are two equations throws people off, and instantly people think, right, this is too tricky because there's two equations, what do I do? You employ exactly the same methods as you've used in previous moles calculations, okay? And that's what I'm going to show you about how to do now. I'm going to approach it in the same way. Also, in question part A, it says, what mass of water would you need to add to the calcium oxide produced from 1 ton of calcium carbonate? Now the fact that a ton has been used instead of grams, again, is a way of throwing you off. Don't worry about it, just use the ton, okay? That's the idea. So, we're going to start off, as usual, by finding out, first of all, what is it we know and what is it we're trying to find out. So we know that there is 1 ton of calcium carbonate, and that is, we want to find out how much water is needed to produce our final product over here, okay? Now, again, don't get confused just because we're linking the two things. Right, so we've done the first bit where we've figured out what we know already, okay? The next thing we're going to do is we're going to work out the molar ratios, okay? Again, very simple, very important. We've got 1 mole of that, producing 1 mole of that, and 1 mole of that. So it's a 1 to 1 to 1 ratio. And then we've got 1 mole of that, which is obviously the same as this is our linker here, reacting with 1 mole of water, and 1 mole of that. So it's all 1 molar ratios, and we are interested in this part here and this part here. So we're looking at a 1 to 1 ratio. Okay, same methods we're employing. So the first thing that we're going to have to do then is we're going to have to first of all start off by working out. Okay, so we know the ratio, but how many moles of this do we actually have? That's the crux of it, basically. So we know we've got 1 ton of this. Right, we have been given the atomic masses of the things that we're interested in. We know our formula triangle because we've got the animals on the bottom, the moles and the ram are on the bottom, and the masses on the top. So, and don't worry about the ton, we're going to stick with the ton, okay? So, in this case then, the mass of, we're looking for the moles of this, aren't we? The moles of calcium carbonate is going to be equal to the mass divided by the relative atomic mass. So the mass over ram. And we know that the mass is 1 ton. There's my ton. And we can work out the relative atomic mass by using these same things here. And if you work out the relative atomic mass of that, it comes out as 100.1. Okay? So in terms of moles, we're looking at, it comes out to a bit of a funky number, which is 0.00998 moles. Now obviously you would just carry on going with this with your calculator, so you wouldn't write it as that, but it's just for the steps that we're talking about. Okay, so now we're going to talk about our bridge going on here. Okay, so we've got that, we're going to bridge down here now. So if we know we've got 0.00998 moles of that, then we must have the same number of this. So the moles of water is going to equal to the same, 0.00998 moles. Easy as that. Now, because we know how many moles of that we have, there's two values that we now know. We know how many moles there are, we can work out the relative atomic mass of water, and we can work out the mass. So that's what we're going to do now. So the mass then, mass of water, H2O, is going, that we need for this, is going to be equal to the moles times the relative atomic mass. It's the same steps we're employing every time. And we know that we have got 0.00998 moles, and we can work out the relative atomic mass of water. Sorry, not of of water. And the moles of water are 18.02. Okay, so 18.02. And when we work that out, we get a mass of 0.18 tons. And that's how much water is needed. Okay, so we use the same principles and things like that. Right, okay, part B then says what mass of calcium hydroxide, would you ultimately produce from 1 ton of calcium carbonate? Now this is much easier than it first seems, because we know how many moles of it we have. We've got 1 ton of that, okay? So we're going to go across here now, and we're going to go, so that was all part A. Part B then. So we're looking at, again, we know how many moles of this we've got, because, you know, we're looking at this now, but it's still the same ratio, so we're still talking about the same number of moles. So in this case then, the mass of calcium hydroxide is going to be equal to, I'm going to write it down here in case you can't see on the screen, it's going to be equal to so we're looking at the mass, it's going to be the moles times the relative atomic mass. Moles times the relative atomic mass, again, same as up there. So we're going to have 0.00998 times by the relative atomic mass of calcium hydroxide, which is 76.14. And that means that the mass of that is going to be 0.74 tons. It's as easy as that. Easy as that. Okay? Right, hopefully that's explained that a little bit.